This next video is going to talk to us about what a histogram is. So kind of like a box and whisker plot, a histogram is another way that we can graph data. Now we're not going to be making our own histograms, but I do want you to learn how to read a histogram. So if you look at this histogram, it looks kind of like a bar graph. And the bars kind of tell you how many, in this case, trees were inside of which one of these heights. So like if you look closely, this guy is really, really short. That means there was not a lot of trees between 100 and 150 centimeters. This guy is telling me that a lot of the trees, 50 of them in fact, were between 250 and 300 centimeters. And then you can kind of see from there how the distribution of the trees is changing. So we have a lot of trees in here, not as many here, not as many there. So you just really need to learn how to read the graph. This histogram shows us the height of a sample of trees. Most of the trees in the sample are between 250 and 300 centimeters tall, most because that's the tallest bar, because that bar is the tallest. And then the shortest bar would be where the least would fall. Everything else would sort of be in the middle. So what heights contain the least number of trees? That would be the shortest bar. Those heights are across the bottom. The y-axis is about how many trees there are in that group. So if this is 10 and this is 0, I'd guess this might be 2 or 3. So it looks like there's about 2 to 3 trees that are 100 to 150 centimeters. That would be the heights that contain the least amount of trees. This group looks like it has about 10 trees in it. So that's more than 2 or 3. This is the least. 50 would be the biggest. All these other ones are in between. So we're really just learning how to read a histogram. About how many trees, so they want to know how many trees are between 150 and 200. So in here, this bar represents how many trees. So you go up and you go over and you see about 30 trees are between 150 and 200 centimeters. Now, histograms come in all different shapes and sizes. Okay? So there's 4 general shapes that we're going to learn. You need to know these words. It's kind of like vocabulary. We've got skewed left, skewed right, symmetric, and uniform. Okay? And you can see pictures of the different shapes. So skewed left, what that basically means is that the peak is up on the right side of it, and then it pulls, we call this the tail, to the left side of the graph. Okay? Pull, this is that pull. In other words, and this isn't a technical definition, but there's only 1 bar on the right side of the peak, but there's 3 on the left side of the peak. 1 on the right, 3 on the left. So that kind of pulls it this way. All right? You might also see it called skewed negative, not necessarily negative numbers down here, but to the left where the negative numbers would be on a number line. So this is another way you could see is that it is skewed towards the smaller numbers. Smaller numbers. So if you look down here, this is 0, 20, 40, 60, 80, 100. It's skewed towards the smaller end, the left end. Then we've got skewed right. So here's that peak, and then it pulls, or the tail is over here on the right side of the graph. So we could call that skewed right. We could call it skewed in the positive direction. We could say it's skewed towards the bigger numbers instead of the smaller numbers. These are all different ways of explaining that type of graph. Okay. Now, right in the middle of that, which would not be skewed in either direction, is what we call symmetric, where both sides of the peak are kind of even or equally split. So the peak is in the middle and the graph falls symmetrically over the 2 halves on each side. We call this symmetric. Nice peak in the middle, whereas these peaks are not quite in the middle. And then the last type is a peak at all. They're all roughly about the same. And we have some off ones, but for the most part, the general shape is that they're all roughly the same height. Height. That word should be height. And we call that uniform, like they're all the same. That's what uniform means. And that's histograms.